Hello and welcome to a new edition of Your Math Notes. So today we're going to talk about solving trig word problems, and this is the first day of it. So let's just begin here. Water wheel problem. Suppose that the water wheel shown below rotates at 6 revolutions per minute. There's some information there. You start your stopwatch. 2 seconds later, point P on the rim of the wheel is at its greatest height. A little bit more information there. You are to model this distance d in feet of point P from the surface of the water in terms of the number of seconds t the stopwatch reads. So let's look at a little bit of information here that I am seeing. It says it rotates 6 revolutions a minute. Usually I want to know how much one revolution is. So if it's 6 revolutions a minute, if I take that minute, which by the way is 60 seconds, and I divide it by 6, it is 10 seconds for one revolution. Okay, so there's a little bit of information there that we're going to be using. There's some other information here too. 2 seconds later, it's at its greatest height. At 2 seconds, it's at its maximum height, aka. You are to model the distance in feet. Okay, so let's go down here and let's see if we can use some of this stuff. I'm going to zoom out a little bit. Sketch a graph of the sinusoid. Okay, well I know at 2 seconds it is at its maximum height. And let's look at what is going on here with this wheel. It's 6 inches to the water, but the 7-inch for the radius, right? So it means we're going to be at -1 when we're all the way down here. So I know already that we are going to be at -1. Let's do this. At the lowest point. Now, at the highest point, we would be 6 plus another 7 above the water here. So we would be at 13. All right, I like to find the halfway point. You like to find the halfway point? Let's do it. So it's 14 from here to here. So 7 up or 7 down from 13, whatever floats your boat, is going to be 6. All right, so our amplitude here is 7, right? Okay, so at 2 seconds, it's at its maximum height. So we're going to put a 2 here, and it'll be at its maximum height. It takes 10 seconds for a revolution. So 10 seconds later, we'd be at 12 seconds. It's going to be all the way back up here for a full revolution. It looks like we're going to be dealing with a cosine wave here. So halfway between 2 and 12 would be 5 places out, right? So this would be 7. And we'll just put a little spot there and there. It's going to be at its lowest point halfway between, right? So, and I'm going to put my dot right here on my 7. We'll put a 7 there. All right, so it looks something like this. There's our sinusoid wave right there. It says write an equation for the distance above the water. Okay, so it does look like a cosine. It is right side up, it's not reflected, and it has an amplitude of 7. So far I know, and I'm using d because this is distance above the water. D equals 7 cosine. Now, pump the brakes. A whole revolution is 10 seconds, but I want to know my frequency. So remember that the period equals, and I like to use radians, so 2 pi over the frequency. Well, the whole period here was 10. So 10 equals 2 pi over the frequency. So then when I solve this, I'm going to tell you right now, you get pi over 5 as your frequency. So this is pi over 5. You can use theta, you can use an x, but you know what? This is time, so we're going to use t. And then where did I start? I start at 2, but in the equation it's the opposite. And then where's my middle? It's at 6. So there is the equation of that beautiful situation. What does d equals -0.5 mean? Well, that is when point P, because that's what we're talking about here, right? When point P is 0.5 inches underwater, right? That's what's going on in the picture. Right here, that's 0, and then that's underwater. So when point P is 0.5 inches underwater. How many times in 1 minute will the wheel have a distance of 0.5? Okay, and that's -0.5. Now this is in 1 minute. Remember, there were 6 revolutions in 1 minute, right? So -0.5, let's look at this picture right here. Do you see this? -0.5 happens here and here. So it's happening twice in 1 revolution. So if it happens twice in 1 revolution, but there are 6 revolutions in 1 minute, it must happen 12 times. All right, so just a little bit of logical thinking there. If it happens twice in 1 revolution and there's 6 of them in 1 minute, it must happen 12 times. Find the distance from the water when. Okay, well, they're saying t is 5.5, so we're literally going to type in 7 cosine pi over 5, 5.5 minus 2 plus 6. Now make sure your calculator's in radian mode, since I do have radians here, but I will tell you it's 1.89, and this is distance, so it's feet. All right, so if you type in the calculator in radian mode, that's what you'll get. Again with this one, so 7 cosine pi over 5, 15.5 minus 2 plus 6. Once again, radian mode, and oh my goodness, you start freaking out because it's the exact same answer, but you know what? It happens. Like, clearly something happens multiple times here. We just talked about it in the last one. So on this one, 0 frightens people sometimes, so we like to throw a 0 at you, but still, radian mode, type it into the calculator, this is what you get. All right, there it is. And that concludes today's math lesson.